Well, here we are. We're ready for test number 2, Chemistry 116, test number 2. As we kind of had in Chemistry 115 last semester, draw a line. And you can separate your notes there. And you know everything that we talk about is going to pretty much be on the test. It's a really good pattern. Remember, we talk about less garbage in, less garbage out. We're going to tell you what you need to know. A lot of cool videos and fun stuff. But all of these videos are going to directly be on the test. Today, big thing. All right, we're going to talk about the periodic table. When you're in, we talked about this a little bit earlier, way earlier at the beginning of the year. When you walked into, 3rd grade, 4th grade, 5th grade, junior high, even biology, even high school, these periodic tables are up in every science lab. Because they look very sciencey. They look, whoa, they look really good. Oh, we must be in it. We must be teaching science. We have a periodic table. But ladies and gentlemen, members of the jury, this periodic table comes to life in college chemistry. High school chemistry, you learn a lot. I mean, I taught high school chemistry for years too, as well as college. But what we're going to learn here, we're going to teach you now. Once again, my degree is in, once again I've taught you, I'm a chemist. Okay, that's my degree. I'm a chemist. So I'm going to have you think like a chemist. So I want to show you something interesting about this particular periodic table. When we come and look, I love this periodic table because the copyright on this periodic table is 1979. Well, once again, I'm not old and I'm not ancient, but I graduated in 1979 from high school. So it's really ironic. It's really ironic that this was the periodic table that was up on the wall when I took high school chemistry. This was also the periodic table that was on the wall when I took all my chemistry classes in college. It didn't change very much. And so what we have is kind of really interesting is that we have gone back and forth with periodic tables because the periodic table is a list of all the known elements in periodic trends, but it shows us the different elements. So sometimes we will put elements together, we'll have a cyclotron, we'll make a man-made element. All of the ones that are clear are man-made. They're synthetic, they're man-made. So we have questions. We just are not discovering new elements, okay? So here's our periodic table, all right? So I want you to know that Dmitri Mendeleev was a Russian chemist. He was given credit for developing the first periodic table. And the key word is it's not just a list of all the known elements. The key word is periodic. Okay? So if we talk about periodicals, that means they have a pattern. They have a reason. Okay? They have a, if it's periodical like a magazine, the reason it's called periodical is because it has a system. It happens in a routine. So that magazine may come out weekly or it may come out monthly. That's what makes it periodic. Well, in this, okay, everything is organized in certain ways that it forms periods, it forms patterns, okay? So the first thing we need to know, other than Dmitri Mendeleev was the first one given credit for developing the first periodic table, is that the first periodic table was pretty limited on just a handful of elements, but he was able to put things in an order, put things in some kind of order. Even though he just had a few elements, he was able to say, these have this in common, these have this in common. Now here's what he did, and here's what we kept with the periodic table. We have right here where groups, okay, you'll need to know this for your test too, groups run from top to bottom, okay? Groups run from top to bottom. Now, this is kind of fun, and I like to show you how we've evolved the periodic table a little bit. This used to be called 1A, 2A, and it was Roman numerals. But chemists have since changed that to where this is group 1, 2, 3, 4, 5, all the way through group 18. Okay? So this is group 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then 13, 14, 15, 16, 17, 18. So now we kind of like that, and chemists change that because remember, chemists are they're not trying to make things complicated. They're trying to simplify. Chemists are about application. They're not about sounding more intelligent. Some of you are sending deals, that sounds good, but what about this? As a chemist, we're not trying to impress anybody. We just want to show what the application is. So groups run from top to bottom. Okay? Groups run from top to bottom. Now, periods run from left to right. So this is period 1. Okay, and it runs from left to right. So period 1 is only hydrogen and helium. Period 2 is lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. So periods run from left to right. Now how can we remember that? Because how do we write? We write from left to right. And what do we end the sentence with? A period. See? So periods run from left to right. Groups run from top to bottom. Okay? So that's a periodic table. Now that sounds pretty good, and you probably learned that. Along the way. Okay? So if we define a periodic table, it is a list of all the known elements. But if you just put that on your test, it's going to be wrong. It's a list of all the known elements in periodic order. In periodic order. This is the key. Okay? In periodic order. So let's look at some. We'll discuss a lot of them throughout this class. Let's look at some of the periodic trends that we can see from this periodic table that as a chemist we can look at and know right away. So atomic size. Not every atom is the same size. The neutrons and protons in the nucleus and the electron cloud around it, okay, whether it's S's, P's, D's, F's, all those things, it's different sizes. Atoms are not all the same size. So what's the periodic trend? Okay, so the periodic trend is whenever we go to the left, okay, and we go down, okay, see here's how we show that. The arrow to the left and the arrow down means that we increase in atomic size. So which is larger? So I could say to you right away, which is larger, a silicon atom or an aluminum atom? And because of the periodic trend, you know that it increases as it goes to the left. So you say, oh, well, hey, an aluminum atom is bigger than a silicon atom. Oh, see? That's kind of nice. So what's the largest atom in the periodic table? Well, it would be the one that's the furthest over and the furthest down. We find francium. Oh, well, that's really cool. Well, we'll study francium a little bit later. A lot of cool things about francium. And being big actually causes francium to really have a lot of problems, have a lot of molecular issues when it combines with stuff. So once again, so let's just do another one. Okay, so an atomic size. What's larger, chlorine or iodine? Okay, well, we learned that as we go down, it increases. So iodine is a larger atom than chlorine. So once again, periodic trends. How cool is this? That we're able to put everything together and it weighs out true every time. Metallic characteristics. You remember we had that last semester. Malleable, ductile, good conductor of electricity. So we say to ourselves, okay, well, how shiny, the different metallic characteristics. What is a periodic trend? The periodic trend for metallic characteristics is the same also. It's to the left and to its down. Okay? To the left and down. So what has more metallic characteristics? Okay? Well, we could pick anything on here. Okay? We could say, we could pick, oh, I love these. Okay? I love these. This is perfect. Okay? This is the perfect example because these elements, remember, I don't know if you remember we were talking about electron configurations, but all of these, copper, silver, gold, and platinum, okay, have one valence electron, which means that they can combine with something. When they have two valence electrons, S2 is full. Because we want S2s, we want P6s. So all of these are the unique in the transition metals. Those are the ones that have S1s, okay? So now I want to know what's the best conductor. I'm putting together a superconductor computer or I'm carrying electric current from one side of the United States to the other. I want to know what's the best conductor. Now, it may be that it's more expensive. I might not be able to do it, okay? But how do I know metallic characteristics? Well, because they increase as they go to the left and they go down. So let's look at this. What's a better conductor? Copper or silver? Oh, well, wait a minute. Periodic trend is down, so silver is a better conductor. Oh, but how come all our electric lines are made up of copper? And then I go to gold. What's a better conductor, silver or gold? Well, gold's a better conductor. Oh, but wait a minute, there's more. What's better conductor, okay, because look, metallic characteristics increase as we go to the left. What's a better conductor, platinum or gold? Oh, platinum is a better conductor. Oh, wait a minute. You mean to tell me if I use platinum, I'd have a better conductor for all the electrons through electric line? Yeah, I would, okay? But we have to look at the cost. So if I'm making one little connection in a supercomputer and I want to solder with something that's going to carry the absolute most conductivity of anything that I can find on the face of this earth, I'm going to look to platinum. And that's why platinum's so valuable. Platinum is rare, it's not readily available, it's extremely expensive. But if all I need is just one little solder amount of something, then I'm going to make it platinum. Okay, so the metallic characteristics, okay, once again, over and down. Now, and you say, well, how do I know all that? Well, it's really amazing because the way the atoms orient themselves, as well as the nucleus with the neutrons and the protons, we find these periodic trends. We find things we didn't even know about, and the periodic trends tend to be true. Isn't that amazing? Isn't that amazing? This chart that was up, all the time that you're in junior high and high school, this chart's up here, but you've never really used it like you're going to use it, and we're fixing to use it. So metallic characteristics, we can tell everything about if it's more ductile, more malleable. Okay. Now the next one we're going to talk about is the periodic trend for electronegativity. Now, I'm going to also ask you on your test, what is electronegativity? Electronegativity is the ability of an element to bond with another element. Oh, okay, so electronegativity means if I've got an element here, and an element here, and an element here, which one's probably going to attract the other ones? The one that's the most electronegative is going to be more apt to draw in and bond with another element. So you say, well, wouldn't the bigger ones just pull them in, kind of like, our universe, the sun pulls in all the planets, so francium would bond with everything? No, it doesn't work that way. It's how the electrons are combined. It's really interesting. So what's the periodic trend on electronegativity to figure out if an atom will bond more with another atom, okay, a particular element from that atom? The electronegativity is opposite of that. The trend for electronegativity is it increases as it goes up, okay, and it increases as it goes right, with one exception. It stops right here at 17. Because what is group 18? We'll talk about the different groups here in a little bit. But group 18 is the noble gases. They don't bond with anything. So when we want to say something electronegativity, that it bonds with another atom, then we exclude the noble gases because they don't bond with anything. We'll talk about them here in a little bit. So if it increases and it goes up with electronegativity, okay, and it goes to the right, then here we set with fluorine, extremely high electronegative element, okay? So let's see what this means, okay? So let's say that we've got, so we're going to talk to you about what bonds with what here in a little bit, but let's say we got a cobalt atom here, okay? Now remember, electronegativity increases as you go up and over, okay? So here's a cobalt atom. Now what's more likely to bond with cobalt? More electronegative, okay? And a little later we'll talk about oxidation numbers, and this really comes into play. So is it going to be, so let's say, is it going to be iron or is it going to be nickel? Well, how does electronegativity go? It's more electronegative to the right, so nickel is more apt to bond with cobalt if we don't have another bond, like a covalent bond or an ionic bond. If we go to electronegativity, then we look at that chart. So once again, periodic trends, let's go over them again. Atomic size to the left and down. Metallic characteristics to the left and down. Electronegativity up and to the right. Now, are there other periodic trends? There's a ton of them. And we'll talk about those throughout the class, but isn't that amazing that this fits? It's like a Rubik's Cube. It just fits in just one way. And so here we go. I'll see you in the next video, and we'll begin talking about the different groups.